guys and girls at home, welcome to Mindset Learn Extra. My name is Pomi and it is of course a beautiful Thursday afternoon. I'm sure that you guys are happy and excited because we're going towards the weekend. But before we can get to that, yes, let's go to the weekend with this special physical science show today. Welcoming in studio, John. Hello, John.
Hi, Pumi. Great to be with you guys. It's really an exciting Thursday. Not usual for us to be doing science on a Thursday, Pumi. Normally we have geography at this time, but today we're doing something different. If you've tuned in for geography, please join us at 6 o'clock this evening. We'd love to have you then to join us for our geography lesson. And we're doing something very important, exactly what we're doing today here in the physical science lesson. We're going to be going over some questions from the June exams because we want to make sure that you're all prepared for your prelim exams. So, Pumi, where can the guys get their notes and all that sort of stuff?
Oh yes, guys, please make sure that you jump on over our Facebook page. It is, of course, www.facebook.com/learnextra. That is where you can post all of the questions that you have because we are here for you guys. So we want to answer all of them. So make sure that you drop them and then I'll try and reply. And again, guys, right here, I have this awesome Casio calculator. And I'm sure that some of you guys at home would love to get their hands on this. So in order for you to be part of that, make sure that you join us on our Facebook page. That's where you can get the link so that you can know whether you are going to win or not. But let me just remind you that the competition will be closing on Tuesday at 8 a.m. So make sure that you get all of your friends to enter as well so that you can also better your chances of winning. Right, John?
Absolutely. And you know what? As you're doing those competitions, the link is there on the page. It takes you to a Curio website. You've got to fill in a special code. It's all on the Facebook page. Enter those details. You enter the competition. And you'll be giving the answers as well. So you'll be able to do some learning. It's not just do the questions, but we're using the Curio platform so we can give you the answers as well. So let's get into what we're going to do today. We're going to start off by looking, as I said, at some June exam questions. Now, we've just come away from winter school, July holidays. You've probably forgotten about the fact that you're on holiday. Had so much work in this first week. But guys, let's just reflect for a minute. It doesn't matter what your mark was in June. Whether you got 10%, 20%, 40%, 80%, 90%, we all recognize that June was just a practice run. In fact, it doesn't matter what you got because it counts so little in the final analysis. The only thing that the June exam counts for is how much you can learn from your mistakes. And that's exactly why we want to go through some questions from the June exam papers. Now, we have taken specifically questions from the Eastern Cape exam paper, but if you've got any questions that are bugging you, as Pumi said, go to the Facebook page, give us a comment, and we'll try and answer them in the third segment. If we can't answer them, we'll give you a reply on Facebook, or we can send them on to the help desk for you. Remember, whenever you're stuck in your studies, help desk is there to help you. Okay, so let's start, and I've already posted the challenge question for you. And on Tuesday, we were dealing with electricity and electric circuits, doing some revision. And the challenge question today follows a similar theme. You won't have done this in the June exam paper, but you might have covered it during class today, or in class this week. So let's just pick up a question about it, and let's have a look and see if you can answer it. We're told a 20 centimeter piece of wire has a resistance, look at that, of 8 ohms. Sorry, that was a typing error. How can you use all of the wire, this wire, to insert a resistance of 2 ohms into a circuit? So you've got an 8 ohm piece of wire, and you want to change that 8 ohm piece of wire into a 2 ohm piece of wire. But you can't just cut a little bit off. Okay, that would be one solution. But they say you must use all the wire. Hey, probably that's crazy, isn't it?
It is.
But you know what? It's possible. Okay. There is a solution, and I'm sure you can get it. Just think very carefully about what you're going to do to this piece of wire. Okay, so I've even given you a hint. I've said to you, draw a sketch of a circuit diagram to see if you can work it out. Okay, now I've chosen some questions from both paper 1 and paper 2 which we don't usually get time to do. We've done some mechanics, we've done some organic chemistry, we've done some of this and that, rates and equilibrium, but we haven't always done enough, I don't think, on some of those other sections that we might just skip out. So in today's questions, we're going to be dealing with this question on forces, revision of grade 11 as well. We're going to do an acid and base question. And if there's time, we'll do a Doppler question. So let's see if we can get it done. Here we go. Look what it says. Read the question carefully. When you get your exam paper, make sure you read carefully. It tells us a block of mass 20 kilograms is pulled at constant velocity to the right. Now guys, as soon as I see constant velocity and there's a force applied, I'm thinking to myself that the net force must be 0, because, and I'm going to write it, and if I were you and I was doing this in the exam, under my question paper, I'd remind myself the net force is 0 newtons. Because if it's constant velocity, then that means the acceleration is 0 meters per second to the minus 2, which means that if you look at F net is equal to mass times acceleration, the acceleration is 0, the F net must be 0 as well. So remember, if an object is at rest or it's moving at constant velocity, we can say the net force is 0. Doesn't mean there are no forces. Please get that right. Doesn't mean there are no forces. It means the resultant, the sum, the vector addition of all those forces together gives you 0. And we're told that it is moving along a rough horizontal surface. It's moving to the right on a rough horizontal surface. As soon as they say rough horizontal surface, my brain goes into overdrive and I start thinking, what does rough surface mean? Horizontal means that there's, if it's going to move, the force must be in that component of that direction. But rough tells me that there is a frictional force. So as soon as I see that word, I know that I must think about friction. So I'm analyzing the paper as I go, the question as I go. It tells me that there was a force of F of magnitude 29 newtons, and then it shows you that this force F acts at an angle of 36 degrees to the horizontal as shown in the diagram. So they're very nice to us. They've given us a diagram, and what we need to do then is read the next part of the question. It says draw a labeled free body diagram to show all the forces that act on the block as it moves to the right. So we need to recognize it's moving in that direction, to the right. It's important that we get this right and we don't make a mistake. We've got to make sure that we have got lefts and rights the correct way around. So learn that and make sure that you're not mixing those up. Left being on the side closest to the margin, right being the side open the page. So you can't get those mixed up in physical science. But let's go back to our diagram. Free body diagram. Now in a free body diagram, the first thing that we do is not a fancy drawing. We just need to do a dot. And the dot represents the box. Onto that box, we now have to identify the forces. So have another look at the diagram that they've given us and have a look at all that we've said in the previous little section up here and think to yourself for a minute, what are the forces that are exerted on the box? You got it? Well, we've identified two of them. We know that there's a force, an applied force at that angle. We've also said, there's a force acting opposite to the direction of motion, which is the force of friction. What other forces could there be? Now, this isn't the free body diagram. I'm just identifying the forces. So what are the other forces? The other forces we need to think about. We know that it's always around, and it's the force of the earth on the object, Fg. And is there a force balancing that pull downwards, that force of gravity pulling down? Yes, of course there is. And we recognize that that force is known as the normal force. It's the force of the surface pushing up on the box. So there we've got the forces. Now we need to draw them together in the free body diagram. So let me get that dot down there, and I'm going to draw the forces as a free body diagram, and I'm going to draw them as straight lines. Very important that you use a ruler for this, and we are going to make sure that if we say that that's the force downwards due to gravity, then the force upwards needs to be the same magnitude. So that's why I'm going to this trouble to get something that is the same, and I'm going to paste the same length over there, and I'm going to put it over there, but I want to just change its color. So let me change its color quickly over here, and I'm going to make it that color. Let's make it yellow so it will stand out. So what we've got here to start with, we've got the force up, which we're going to call the normal force. We've got the force down, which is the force due to gravity. We also said that there is a horizontal force. Let me put the straight line in. The horizontal force was the force due to friction, acting in the opposite direction to motion. And then we mustn't forget that there was another one which I'm going to choose acting at that angle. Let's just make sure that we've got the force on the dot and it's all sorted out. Now, I haven't made these arrows because the arrows aren't very big, aren't very clear, so I'm just going to put the arrows on top there. You would obviously not draw them like that. We need to draw carefully. This is the force applied. This is the force of friction. Now, is that good enough? We've drawn the free body diagram. We've put little symbols on the forces, but we haven't fully labeled it. So it's very important when you get a question like this, making sure that the lengths are the same for the normal force and the force of gravity because it's on a horizontal surface, that it's drawn roughly to scale, that we've got the idea that it's more or less the same, as the distance is comparable. The next thing, though, we need a key. We need to say what that Fn stands for. And we're going to need to put a key here to say that this is the normal force. We're going to have to say that Fg is the force of the Earth, or known as weight. Force of Earth on the box, and we can even call it weight. And the next one, the force of friction, that's the frictional force. And the last one, which we put in over here, was just the applied force. Right. I hope you've got that. Now, it's very important that we use this diagram to help us solve the next question. So let's move on to the next question and see exactly what it says. It says, calculate the magnitude of the frictional force that acts on the block as it moves to the right. Now, guys, this is extremely important, and we've got to get it very clear. What we know is that the frictional force must be equal. If we look back at our free body diagram, the frictional force was a horizontal force. Let's go to the free body diagram. And that tells me that there's nothing, these two will be the same magnitude, equal magnitude, opposite direction, so the resultant of that is going to cancel each other out. What we recognize next, though, is that the horizontal force here must be cancelled out. And I think I've made a mistake there when I said that those are equal. The component plus need to go into there. So let me just alter something here, because I think I've made a little bit of a mistake, and I'll explain it to you now. I'd rather correct myself than not correct it here. What we know is that this is the only horizontal force. So the component of this applied force, these two must be equal. Now, they don't look equal, but they must be. And then what we're going to say is there's a component that is a vertical force, a vertical component. And what we're going to need to recognize is that this one plus that one, those two together must equal the Fg. Fortunately, we don't have to deal with that just yet at the moment, but we will come back to that in a minute. So what we are going to be able to find is we're going to be able to find the horizontal component of the applied force. And that will help us very much in solving the question. Remember, we've got the angle of 36 degrees. Now, do you remember how to get the horizontal component? We need the horizontal component, so that's the adjacent side. So we're going to say, let's find the horizontal component, which is going to be F applied times what? Times cos of that angle theta. That's what we need to find the horizontal component. We're just using the definition of cos theta there. So what was the applied force? They gave it to us. They said it was 29 newtons. This cos is an angle of 36 degrees. And now we just have to work it out. So let's get the calculator out and let's see how we go on that. So we're going to say 29. Let's just make sure that this doesn't give me a problem. I'm going to get up that calculator again. We're going to say 29 times cos of 36 degrees. We close the brackets and we get that is equal to 23,46. Now remember, whenever you're doing a calculation, to round it off to 2 decimal places. So we're going to write that down, 23,46. So my horizontal component is 23,46 newtons. And because of our discussion, recognizing that the F net is equal to 0, then the horizontal component must be equal. Therefore, F friction is equal to the horizontal component of the applied force. So the frictional force is 23,46 newtons. Notice that they didn't ask you to find its direction. They simply said magnitude. They asked you for direction, you'd have to say to the left, okay? Not to the right. The object was moving to the right, frictional force is in the opposite direction. I think there's time just to squeeze in the next part of the question, and because it's very short, so let's just go to it. It says there's now the force now acts parallel to the surface. So it's not acting upwards, it's acting parallel. And what we've got to say is, will the magnitude of the frictional force between the block and the surface increase, decrease, or stay the same? Now guys, what you've got to recognize is if the block turns horizontal, then it loses its vertical component. If it loses its vertical component, then the acceleration is going to be bigger, there's going to be more kinetic energy being used, and so we're going to find the frictional force has got to cancel some of that out if it is accelerating. Even though it's accelerating, it doesn't say it stays at constant velocity. So it will accelerate, but the frictional force will increase because the vertical component is no longer lifting the block upwards. And that's exactly the explanation that I would give here. Explanation for the answer, the component, the vertical component of the force doesn't lift the block up. Was lifting the block up. Lifts up. It adds to it. We drew it in the free body diagram. Now if we make it horizontal, it doesn't. In other words, the normal now has to increase. F normal increases because F normal has to be the same as Fg. And if F normal increases, remember how we calculate the frictional force. The frictional force, and this is important, last point, we're going to say the frictional force is equal to the component of kinetic friction times the normal force. So if F normal increases, then the whole thing, the frictional force must increase as well. Pumi, I know I've gone over time a little bit, but we've got to the end of the question.
Alrighty, thank you so much, John. Please make sure that you come back after this ad break as we try and answer all of your questions. Don't go anywhere. Welcome back from that ad break, Mindsetters. I'm sure that you're happy and excited as we are going through physical science question papers. So make sure that you get all of your friends to tune in as well, because this is a special broadcast. And if you are watching because you want to see geography, worry not, because we will be doing geography at 6 o'clock. So make sure that you do not touch that dial. Anyway, guys, please make sure that you also post all of your questions right there on our Facebook page. It is www.facebook.com/learnextra. John.
Thanks, Pumi. Guys, let's get going now. Now we've done a physics question. It happened to be question number 2 in the Eastern Cape exam paper. We're moving on now to a chemistry question. And this was one of those chemistry questions that came right at the end of the paper. And it's on a new section. And so I really think this is important to practice, because there are not many questions around on acids and bases, because for the last couple of years in the previous exam papers from 2008 until last year, the NCS papers did not include questions on acids and bases. Guys, I've got a hint for you. If you want to find some questions, and there's some meanies in this section, some real tough questions, go and look at the senior certificate examination papers. And they've been writing those as well as supplementaries. Go and look on the websites and we'll see if we can get some to you as well. So it's really important you practice this. It's not that difficult, but you have to think carefully. So let's go and look at this Eastern Cape question. Here we go. It tells us that a grade 12 learner finds some sulfuric acid, which is given the formula of H2SO4, which you should know, in a bottle labeled dilute sulfuric acid. The learner wishes to determine the concentration of the sulfuric acid solution. To do this, the learner decides to titrate the sulfuric acid against a standard potassium hydroxide solution. Now, wow, there's lots of terminology there. So let's just make sure that we understand the principle. Learner picks up the bottle, sees dilute sulfuric acid. Doesn't have a concentration. Remember what concentration is. It's the number of moles divided by the volume of the solution. Number of moles of solute, it's number of moles of sulfuric acid in the total volume of the solution. And we don't know how many moles per decimeters cubed there are, moles per unit volume there are. So he wants to find, or she wants to find out exactly how concentrated or dilute this solution really is. The next thing they say is they're going to do a titration. Now, titration means you're going to take a little bit of acid, put it into a beaker or into a conical flask, and then you're going to add base to it until they react and they neutralize. So the same number of moles, or the ratio of the moles of acid to the moles of base, will be in proportion to the equation, and the reaction will be complete. So if for every one acid molecule we need, in this case, 2 hydroxide molecules to neutralize it, then we need a ratio of 1:2. And at the end point, that means that we've matched it all up and we've got no more reactants. We've only got product. That is the aim of the titration, to find exactly where you've got the correct number, ratio of moles of acid to base, so that you've got no reactants and only products left over. So that's what the titration is all about. Now, they also give you this word which comes up here, standard solution, standard potassium hydroxide solution. We'll come to that in the second part of the question. So first of all, what does it dilute mean? Well, remember, concentration is the number of moles per unit volume, as I've said. So dilute means when you have a small number of moles of your acid or your base, small number of your solute in a large volume of solution. That's what we call dilute. But now, I'm wanting to do some revision here as well. So what would concentrated be? Well, it would mean a big number of moles of the solute, like H2SO4, in a small volume of solution. Now, remember the sulfuric acid itself has a volume, so it's not in the volume of the solvent that we add, but it's the total mixture. That's what we want the volume to be. And that's very important when you come to make a standard solution. And you should know how to make a standard solution, where you find the mass, and we're going to do the calculation just now, of the potassium hydroxide as the example, and you then dissolve it in a specific amount of water so that it's all dissolved, and you do that in a conical flask. Very important practical idea. So here we come to it. What's a standard solution? I've just described how to make it. A standard solution is a solution of known concentration. So I can say, I know that there are exactly 2 moles for every liter of this particular substance in that quantity of water, or that solution at least. So I know exactly what's there. Now comes the calculation part. It says calculate the mass of potassium hydroxide, which the learner must use to make 300 centimeters cubed of 0.2 mole per decimeter cubed solution. Sure, guys, I need to be very careful here. I've got some information and I need to work with it. So let's pick out what information I've got. I've got the concentration. The concentration, 0.2 mole per decimeter cubed. That's what I want to find. Now remember what I said to you, that concentration is equal to number of moles divided by volume. We also know that number of moles is equal to the mass divided by the molar mass. And if we put those two equations together by substituting for N, what you'll be able to see is that the mass is equal to the concentration times the volume times the molar mass. This equation isn't on the data sheet. Hasn't been on the data sheet for the last couple of years. I don't think it's going to be on this year's data sheet. So you're going to need to know how to work this particular thing out. So what do we know? We've got concentration. What else have we got? We've got volume. Yeah, we've got volume. It tells us 300 centimeters cubed. Now, can I leave it as centimeters cubed, guys? Think about it. I've got concentration in decimeters cubed. The SI units for volume are decimeters cubed. So I can't leave 300. I've got to divide by 1,000 and make it 0.3 decimeters cubed. Okay. Be very careful about that. Next one. What am I missing? I'm missing the molar mass. I want to find the molar mass of potassium hydroxide. Now, Pumi, you know what? I don't think I've got a periodic table up here. So we're going to need to just check this very quickly. And you're going to have to check, just do a Google search for me. I need to know the molar mass of potassium. I think it's 39, but you just quickly look it up. Just molar mass potassium. I think it's, as I said, 39. We'll correct it if it's not. Oxygen, I know, is 16. Hydrogen is 1. Am I right?
It's 39.
39, there we go. So that's 40 plus 1 is 56. And so there we go, 56 grams per mole. Okay. So now I've got the concentration, I've got the volume, and I've got the molar mass. I'm now going to use my calculator. So let's go to the calculator and let's see what's going to happen here. I want to take that ink off and use the select button, and that's fine. It will help me now, and I just need to clear everything. and I'm going to say I had 0,2 was the concentration. I times it by 0,3, which is the volume. Remember, I'm using decimeters here. And then I must multiply that by 56. And the 56 is the molar mass. We multiply those together, and it gives me the answer of 3,36. And that's the mass that I need. So the mass is equal to 3,36 grams. Now, please, when you do it, set it out neatly. You can either use my equation, this one, and do the substitution, or do the two-step process. It really doesn't matter, but you must show your working and your substitutions. So be very careful about that, and you will see that you get that correct answer. Let's move on. Got a few more minutes, and let's look at the titration. So when we look at the titration, we'll begin to see that there is the balanced equation. You'll see you need 2 moles of that for 1 mole of that to produce 1 mole of that and 2 moles of the water. What we're doing is we're saying the titration, the learner finds that exactly 15,04 centimeters cubed neutralizes 20,15 centimeters cubed of sulfuric acid. The equation for the reaction is that, and we now are asked some theory questions before we get into the actual reaction. So what's the importance of adding an indicator? Now guys, here you've got to think. If we're saying titration gives you the point when you've used up all the reactants and you've only got products left, how are you going to know when you reach that point? Because these are colorless solutions. There's no indication that that's happened. So what we've got to do is we've got to add an indicator, and the indicator tells us this changes color. The indicator changes color close to the end point, close to the equivalence point at least, close to the point of neutralization. And we call that point of neutralization, we call it, when the indicator changes color, the end point. If you don't use the right indicator, and that's what the next question's about, if you don't use the right indicator, you might not get the exact point. Fortunately, most indicators change in a range, and that equivalence point is very sharp. It happens within even half a drop. We get the exact point, and it's quite fun to see that changing. So when we look at that, we've got to decide which one of the following indicators listed below is the best one to use. Now, here's the principle, and I want to get this to you very clearly. What we've got is potassium hydroxide, which is a strong base. And we've got sulfuric acid, which is a strong acid. When you put a strong acid and a strong base together, the end point, the equivalence point, is at around about the neutral point. It's at pH of 7. So we need to understand that when they neutralize, look what's happened. We will make, from the equation, we will make a salt and water. We know the pH of water is 7. And if it's a salt made from a strong acid and a strong base, it will not change that pH. That salt will be neutral. And so we want an indicator that's going to change color as close to 7 as possible. Now look at the indicators that we're given. Because we were given a strong acid and a strong base, and the only one that's in that range is bromothymol blue. And what's interesting about bromothymol blue is that it changes from yellow to green to blue. In base, it's blue. At the end point, it is green. And in acid, it is yellow. So you can see very clearly, one drop. Is it still yellow? And you swirl it around. Does it stay yellow? And you've then got to add another drop and see, might start to change. You see a little bit of green forming. If it goes to blue, you've added too much base. You then got to add a little bit of acid and so on, until you get to the point that it's exactly green. And hopefully you can get that. So bromothymol blue is used for strong acid plus strong base. What about methyl orange? Well, guys, here, look at this. This range here is acidic. It's below 7. It's on the acidic side. So if you're going to get the indicator changing at this point, the solution, the salt, will be dissolved in water, and the salt itself is a weak base. Weak bases form weak acid. It's a weak acid. And weak acids form when we have a strong acid and a weak base. So when you take a strong acid, something like hydrochloric acid, and you react it with calcium carbonate, something like that, you are going to get into that endpoint. Whereas this one, you want a weak base plus a weak acid plus a strong base. This is weak acid, something like, let's take a look at something like vinegar, your acetic acid. It's a weak acid. Strong base, sodium hydroxide. And what will we get? We'll get sodium acetate, and that sodium acetate salt gives you a pH of above 7. And so the phenolphthalein is the best indicator there. Please learn that process of discussing and describing indicator changes. Right, I think we've got time to do the last problem, and that was the calculation of the concentration. So we've got the information there. Now there are two ways of doing this. You can use the formula that's been given, and the formula is just plugging it into the formula. I want to show you the thinking way of doing this problem. And the thinking way says to me, well, how much of what substance do I know? I know the concentration. I know the concentration of the sodium hydroxide. I was given that. It was told to me earlier on in the previous question when we had to work out the mass. If you remember, we wanted it to be 0.2 mole per decimeter cubed. So we know the concentration of that of the potassium hydroxide. So the concentration of potassium hydroxide, we know. We know it's 0.2 mole per decimeter cubed. And the other thing that we know that we are going to use 15,04 centimeters cubed of that. So the volume here is the volume of potassium hydroxide. Now you'll see that I'm labeling it very carefully. It's 15,0204 centimeters cubed. Okay? I don't like that writing, and I'm going to just redo it because I will confuse myself. 15,04 centimeters cubed. Now, what I need to recognize from the equation, I need 2 moles of that with 1 mole of that, just because that's a 2 and there's a hidden 1 over there. So the first step that I like to do when I do this equation is I like to say to myself, how many moles of potassium hydroxide do I have? And I'm going to convert this by dividing by 1,000 to decimeters cubed. The number of moles is the concentration of the base times the volume of the base, and I'll get the number of moles. So what do I know that is? I'm going to say it is 0.2 times 15,04, but I'm going to divide by 1,000. Another way of dividing by 1,000 is multiplying by 10 to the minus 3. Let's get the calculator out, and let's put that into the calculator so that we've got it clearly written down. And there we go. We're going to put 0.2 multiplied by 15,04 exponent minus 3. It's a tip from me. if you're ever wanting to do your conversions, do them in scientific notation. Work out what you need to do. Multiply by 10 to the 3, divide by 10 to the minus, multiply by 10 to the minus 3, multiply by 10 to the minus 6. It works beautifully, particularly if you've got a Casio calculator to help you on your way. So there we get the answer. It's 3,008 times 10 to the minus 3. So I'm just going to round it off, 3 times 10 to the minus 3. So there we go. That's equal to 3 times 10 to the minus 3 moles. Now, guys, what we said, if we have 2 moles of potassium hydroxide, the ratio is 2 is to 1. So for every 2 moles of this potassium hydroxide, we need only 1 of sulfuric acid. Why? Because we've got one of the, for every 2 of those, you've got 2 of those there. So be aware of that ratio. So that means I'm going to need half the number of moles. So the number of moles of acid that I require is the number of moles of base divided by 2. Please understand how I got that. I said I've got 2 of those, I've got 1 of those. They must be in the ratio of 2 is to 1. So I can't say I'm going to have 1 to 1. I'm going to take this number, potassium hydroxide, and divide it by 2, because to go from 2 to 1, I'd have to divide by 2. So let me write it down. 3 times 10 to the minus 3 divided by 2, which is going to give me 1,5 times 10 to the minus 3, and that is moles. Now, what was the last step? The last step was I need to find the concentration of sulfuric acid. Now remember, concentration is the number of moles divided by volume. We've got the number of moles, 1,5 times 10 to the minus 3. What about the volume? Were we given the volume? Yes, we were. 20,15. So I'm going to put the 20,15 into this equation, but that was centimeters times 10 to the minus 3. Let's get the calculator out again, and let's see if we've got it. Now, I'm going to start by dividing this by 2. I'm going to start by dividing by 2, which will give me my 1,5. I'm then going to say, that's the top line, the denominator. Let's divide this by 20,15 exponent minus 3. Close my brackets just so that I've got it all sorted. I don't even need a bracket there. It should all be fine. Get an answer. Oh, no, it's told me that I've got a syntax error. Let's go back. Let's clear it and put this on again. It's not helping. So I'm going to let's just turn that off for the moment. And let's just do that one more time. 1,5 exponent 3 exponent negative 3 divided by 20,15. Let's delete that. Exponent minus 3. And we get an answer of 0,07. And I'm going to round it off to 2 decimal places. Even though it says 0,774, I'm going to say, let's write down 0,07 as my answer. And that's where I'm going to leave it. Equals 0,07 mole per decimeter cubed. Pumi, I know I've gone over time, but let's take a break now.
All right, cool. Let's take a break, guys. Welcome back from the break, mindsetters. We are still doing physical science, and of course it is the special broadcast, so make sure that you join us at 6 o'clock if you are tuned in already for geography. We are definitely giving away the Casio calculator, so please make sure that you tune in, and also make sure that you get all of your friends to participate, or rather enter it, because we are closing it at 8 a.m. next week Tuesday. Anyway, guys, to all of the great 12s that participated on the physical science challenge questions, thank you so much. I can see there's also Karabo Mabene there, who also wanted to share his picture. You know,
That's great.
yeah,
Great.
that's really
Very
fantastic. So please make sure that you do all of that so that we can always get to help you guys. And also remember that you can log on to our help desk in order for you to ask all of the questions that you feel like we didn't get to answer because of time. Anyway, John.
Let's get going.
Yeah, let's do it.
And guys, I hope you've been following. We've done 2 questions, one on physics, one on chemistry. Let's kill the challenge question now.
Oh,
So
yeah.
I've seen that there are quite a few little posts on here, and it's quite an interesting question. So let's just explain a little bit. So you've got this long piece of wire, 20 centimeters long, and it has a resistance of 8 ohms. Got it? 8 ohms. And what we're asked to do is to use this piece of wire to make a 2 ohm resistor. Now, what you should be thinking, I know that the thing that makes resistance smaller is if I put resistors in parallel. You can think of that long piece of wire, 20 centimeters, as 8 1 ohm resistors all connected to each other. So let's just do some fun here, and let's just say to ourselves, that's a 20 centimeter. We could have divided it and said the first, that was 1 centimeter. That was equivalent, it's not 1 centimeter at least. We're dividing by 8. We can't really get that division clearly in our heads. But the first little bit, if we divide it into 8 equal pieces, then the first little bit would be 1 ohm, and the next little bit would be 1 ohm, and the next little bit would be 1 ohm. And if these were all equal, and we had 8 of them, so that was 1, 2, 3, 4, 5, 6, 7, and there's my 8th one, make it the same length, and we're saying that's 20 centimeters. Now guys, we would recognize those all in series. We want to reduce it, so what do? Well, the one thing that we could do, remember we're targeting it to be 2 ohms. And the one thing that we could do is say, well, at about halfway. So if I did this, and I took a loop, and I twisted it like that, and I would then say, I've got 4 centimeters over here, and I've got 4 centimeters over here, and half of that also means, 10 centimeters and 10 centimeters. I'm getting confused. This is 4 ohms over here and 4 ohms over there. Halfway. Just twisted it like that. Now, because it's joined over there and it's joined over there, that means that this has formed a parallel branch. And what do we know about resistors in parallel? Well, they form an equivalent resistance. And we say 1 over R parallel is equal to 1 over R1 plus 1 over R2. So if we do that, we'll get 1 over a quarter plus 1 over a quarter, which tells me that I will get 4 as my common denominator. 4 goes into 1s plus 1. That gives me 2 over 4, which gives me a half. Do you agree? I hope you do. But now, is that my R parallel? No. I've got to say, therefore, let's invert. If we invert my R parallel, then I will get 2 over 1, which is 2 ohms. Isn't that cool? So all you have to do to take this 20 centimeter piece of wire and make it into a 2 ohm resistor is just to put it in half. Then you've got 4 ohms, and there you go. Now I want to show you a really interesting little trick that will help you when you've got 2 resistors in parallel. Guys, you can't use this method in your exam. You can't put it down, but you can use it as a mental check to see that you've got the right answer. And I'm just thinking to myself whether I've got the right answer, because I'm going to do the mental check now. And the mental check, if you've got, it only works for 2 resistors in parallel. What we do is we take the product of the resistors and we take the sum of the resistors. We say product over sum. 4 times 4 is 16, and 4 plus 4 is 8, and 8 goes into 16 twice, and there's my check. It's done. Isn't that amazing?
Wow.
So you can do it really quickly. And guys, if you've got 3 resistors in parallel, don't use this. It doesn't work. Okay. So this is just a quick thing. Never use this in an exam. This is just for you to check that you've got it right. And you can put it down correctly. Okay. You liked that, didn't you?
Yeah, I do. I really liked it. I didn't really look at it in that way.
Okay, so there you go. And now, you can actually show that this is always true. Pumi, are there any questions on the page?
Up to so far, I'd like to believe that all of the mindsetters at home are catching up, hey? Because they're not even asking.
Okay,
So
cool, guys. I hope you're following. I hope you've got this covered. I'm sure you have. There's one little thing that I want to speak to you about before we do the next question. And that is, you know, at Mindset, we do all sorts of fun things. And Learn Extra is really fun, helping you to learn extra, learn more, and have fun while you're learning. And one of the things that we're promoting this week and for the next couple of weeks is we're really concerned about the environment. I'm particularly concerned about the environment. We recognize global warming as an issue. Pumi, you recognize it as well. Mm-hmm. Okay? And one of the critical things about global warming is that it's going to affect our water resources. And so we've got to manage water a whole lot better. And so to start a discussion about water management, some of the topics are covered in other subjects, but in physical science we do a little bit about water in grades 10 and 11. But it's topical. And for you grade 12s, I think you should be engaging with current issues and science and issues. So we've got a special game for you to play. Now, I don't want you to play all night, but just to go and have a look. There's a competition at the following website. It's called watergame.co.za. Please go and have a look at it, register and play. It's a South African environment, and you can make decisions about how to manage the water in that catchment area. You're given the opportunity to plant crops, to build dams, to build factories, to feed people. The more people there are, the more water, the more food, and so on. And it doesn't take very long. There are 12 turns. You can finish it in about half an hour, and you get a final score. You can then go back and try and beat your score. And here's the exciting thing, Pumi. The person that is at the top of the leaderboard at the end of the month, in other words, on the 18th of August, because we started on the 18th of July, the end of the 18th of August, they're going to win a great prize. They're going to win 5,000 Rand.
Whoa, now
hey,
that's a lot of money.
And you know what, guys? It's not just about the 5,000 Rand. Mm-hmm. Along the way, there are spot prizes as well. So play, the more you play, the more you win. Okay, let's get on to this question, because we haven't spent much time on this particular topic. The question reads as follows. It says to you here, we've got a sketch below that shows a car traveling at a constant velocity of 140 kilometers an hour. Hey, I don't want to be in that car. It's going over the speed limit. And it's traveling behind a truck that's moving in the same direction at a constant velocity of 110 kilometers. Well, which is more dangerous, do you think? A truck traveling at 110 or a car traveling at 140? In my opinion, they're both breaking the rules of the road, okay? Because the truck has a much bigger momentum, and it's going to be harder to stop that big mass from traveling so quickly. The car, smaller mass, will be able to stop easier. That's not what the question's about. But when you read questions, you need to be thinking about these ideas of physics. So what we recognize is the relative motion between these two. But look what it says. The driver of the car notices a red badge on the back of the truck that reads, if this badge is blue, you're driving too fast. And so it now tells us to do the following. Use the Doppler effect to explain the claim made by the badge. Okay, so let's remind ourselves about the Doppler effect. The Doppler effect says to us, if we've got a source, whether it be sound, whether it be water waves, or whether it be light, and you've got somebody approaching that source. Source is stationary. Somebody approaches that, then they will not hear or see or observe with water waves those waves having the same frequency as the source. So, excuse me, in this particular example, we've got the red badge. And the red badge is on the truck, and what we've got, let me just move that to this side. What we've got is the car that is moving towards it. So if we made the truck stationary, and this is all about relative velocities. So let's have a look at the relative velocity between these two. In effect, this is traveling at 120. This is traveling at 140. What's the difference between these two? 140 versus, you can see that there's a difference of 30 kilometers per hour. So in effect, relative to the truck, or the observer on the truck would see this car approaching him at 30 kilometers an hour. The driver in the car would see himself closing the gap at 30 kilometers per hour. So what we recognize is that we've got the car moving forward. If this was stationary, imagine this was stationary, and at 30 kilometers an hour, he's approaching this red sign. So the light, he's moving towards it. And what we recognize Doppler says, if you've got a stationary source and something's approaching it, then the frequency will appear to increase. So we'd expect, if this was sound waves or so on, there'd be an increased frequency. Because it's getting closer to a stationary source. If it was moving away from the source, then the frequency would decrease. So now I've got to ask myself, red light has a long wavelength and it has a low frequency. Okay, that's red. But blue has a short wavelength, so it has a high frequency. And so what the physics behind it saying is, because you're approaching this truck, you're moving quickly towards it, there's going to be a change in the frequency or the perceived frequency of light. That's what it's about. So we're using Doppler. We say the following. Doppler tells you that as an object approaches a stationary source, or a source moves towards a stationary person, or there's relative motion between two objects. Relative motion, in this case, the truck is moving slower and the car is moving faster, but relatively they're moving towards each other at 30 kilometers an hour. Then we would expect there to be a change in frequency. The frequency must increase. Those waves will get closer towards each other. And so we could get a change from red to blue. Problem is, it's not going to happen, because we've got to consider the velocity of light. And the velocity of the source is the velocity of light, which is c. But that's the second part of the question. So I hope you understand that in terms of this question, we're almost done. The reason it won't work is because the velocity of light's too big. Pumi, I can see you waving. Time to go.
Yes, it's
Guys,
time
it's
to
been
go.
great being with you. We'll see you again.
Oh yes, guys, thank you so much for tuning in on our special broadcast for Physical Science Grade 12. Remember that the geography will be coming back. We'll be doing geography at 6 o'clock. Right now, guys, it's time to love and leave you. Bye-bye.
Hi Mindsetters, great to have you with us today. Now I've got an important announcement to make. Some of you have just come back from the July holidays and you may have missed our winter school. We had great fun and we had some great prizes to give away. Today I want to announce and make sure that everybody knows that our winner of our winter school competition was Rafilwe Saboko. And we really want to say thank you to Intel for sponsoring this Asus T100 laptop notebook, that tablet at least, that will be really useful to Refillware. Thank you for everyone that participated and joined the competition and also registered on the Explore and Learn application. Really want to encourage you all to get onto that website. We'll post the link on the page as well, and make sure you participate to get some great content from Explore and Learn. So from me, make sure that you join us and keep tuned in to Learn Extra, because we've got more great competitions coming your way.